Welcome to Crying Out Cloud, the podcast that will make you laugh, cry, and reconsider all of your cloud security fears. I'm Eden from the CTO team at Wiz, and I'm here with my fabulous co-host, Amitai, from the threat research team at Wiz. And we are about to dive into some crazy stories going down in the cloud. Let's do it.
Let's do it.
What are our stories for today?
Our first story, the LAPSUS hackers have been tried in court, and some of their identities have been revealed. We're going to talk about that.
This is a crazy story.
Mm-hmm.
And our second story?
We're going to talk a bit about data poisoning during AI model training, and some research that's come out about that.
Is there an antidote?
I hope so. That we'll leave that as a mystery for the end of the episode.
Coming soon. And our third story?
So crypto traders, our favorite subject for this podcast.
They
apparently.
come up every week time.
They're just a good target. They've been targeted by a 0-day in WinRAR, and which is, we've discovered, is a very strange word to say. Try saying RAR.
10 times.
Yeah.
WinRAR, WinRAR, WinRAR. All right, let's start with the first one. The LAPSUS hackers revealed. LAPSUS, if you don't already know, are a prominent hacking group, and they became famous for breaching a bunch of huge tech companies, Microsoft, NVIDIA, Samsung, like they were in the big leagues. And they did it very punky.
Yeah, like they did it with a very punk style.
Yeah.
Where like they made fun of the victims and like they stuck around even while the investigation was ongoing, and like they sent messages to the investigation team, like trying to like tease them out.
Alluding to the fact that they might be kids doing some shenanigans.
Or people who are children at heart.
Children at heart,
can't know.
Never know. But two of the members were found guilty of criminal cyber activity in a UK court. And then it came out that they had a rival group that doxed one of their members, which is what led to the arrest. Juicy. And then what's even crazier is while they were under arrest and they were like under house arrest, the activity continued. They kept hacking.
Like this is one of the things I think that the court case revealed that I don't think was known beforehand, which was also kind of strange. I remember for me, like reading about this in real time, because I think about a year ago is when LAPSUS started being active and sort of getting into the news. And then it was like, okay, but they're actually a group of teenagers from the UK. And I was like, okay, so it's probably going to stop now, right? And then it was like, okay, they've been arrested. And then suddenly it was like, wait, but LAPSUS is still doing stuff. And now we know why.
And how? This is crazy. Ready for this?
Yeah.
How did they do it?
So apparently they were sort of under house arrest, but like in a hotel. I don't know how that works. I think part of it was like to...
It has room service and...
I've never been in a hotel. How does it, what do you do? So anyway, apparently a thing you get in a hotel is like a smart TV, right? So apparently one of them was put in a room with a like an Amazon Fire TV stick, and somehow he had a mouse and a keyboard, and he just connected it to the Fire TV stick, and then he just went on hacking.
Which is crazy. And alludes to kind of opening the question of how we like work with a young group of hackers and how we kind of understand their behavior. And this was something that the US government began looking into.
Right.
They have the Cyber Safety Review Board that did an investigation into LAPSUS. And what are we doing wrong here that these teenagers can hack into these huge companies? And what were some of the takeaways? Yeah,
so if the teenagers could do it, then the Russians can probably do it, and the Chinese can do it.
And the North Koreans too.
Yeah, and if they happen to be Chinese teenagers, then wow, like that's like top tier hacking, right?
Amazing.
So yeah, like all of this was pretty embarrassing for the US and those in charge of American cybersecurity. A lot of these big targets were American companies. So like the US government was like, how the hell did this happen? So they set up this cyber review board. I think the last thing they published was about Log4Shell and like looking into how that could have been prevented and some takeaways from that. Their latest report is about LAPSUS.
Our friends LAPSUS.
Yeah. So they came to a few conclusions that you can read about in their report. There's a link in the description. One is that a lot of the companies that were targeted were basically service providers for other companies. And a lot of the companies that were targeted didn't necessarily realize that their data was being held by these other companies. Because nowadays, it's a very interconnected world. If you have a company, you probably have many different services that you use in your cloud environment, for example.
And so this is like a blind spot.
Yeah.
It's the third-party service providers.
Yeah, like if you're doing risk management and you want to understand where your data is and where it might be a risk, often you're sort of looking, you have like tunnel vision and you're looking at your own environment, but you often have to take into consideration that other organizations have access to your environment and your data is probably being held all over the place.
Yeah.
And this is one of the things that came out of this review, that a lot of organizations probably aren't putting that front and center in their risk models.
Another one that I thought was really interesting is like, how do you create opportunities to divert young hackers, juveniles, to legitimate cybersecurity careers, so they actually like have a path to move forward?
Yeah, so I think a lot of countries have, the way they've solved this, at least partially, is, okay, you have a youth who hacked into, well, hopefully not like a 2-year-old, but yeah. I mean, if they're a toddler, then good for them.
Breaking news, 2-year-old hacks Microsoft.
Right. So anywhere in the range between like 2+ and 18. So there's still a chance to reform these people and sort of say, okay, you're really good at what you do. You have a natural talent for this. Maybe it would be better applied if you were working like for the government.
Set against them.
Yeah. So a lot of countries have programs in place where like they might give you a plea bargain and they'll say like, okay, you did this bad thing, slap on the wrist, and then come work for us so that you don't go to jail for the rest of your life. And what the review board has said here is that we're not good enough at this, because apparently, like in this case, the hackers were from the UK and from Brazil. But if this had happened in the US, the review board is saying we probably wouldn't have done a much better job of making sure these people didn't arrive at the point in their lives where they were hacking Microsoft. And we probably could have identified it earlier, like when they were like in I don't know, in middle school.
Middle school hacking club.
No, like their teacher could have noticed that maybe they were
talented.
Yeah, talented and underutilized and doing stuff that they shouldn't be doing.
And another interesting point that they talk about is that like LAPSUS use very low cost techniques, which could kind of open a question about why these techniques were so successful and how do we avoid them?
Yeah, like really low hanging fruit. Like they were going after, they didn't have any 0-day vulnerabilities. They weren't doing anything particularly sophisticated. They did seem to have a good grasp on the environment. Like one of the things that we noticed was that they definitely knew their way around cloud environments once they got into a target. But they weren't doing anything especially sophisticated. Like, and again, this is why it's so concerning, because you've got to assume that Chinese threat actors and Russian threat actors that are going after American targets probably have a lot more in their arsenal than a bunch of teenagers who just have like money, and probably not a lot of it at that. They just have, I don't know, pizzazz.
Spunk.
So like one of the things that I remember that they did was they put up notices in like forums saying, if you work at, I don't know, NVIDIA, we will pay you $1,000 if you give us access to your user.
Brilliant.
Right? And it worked, right? Or supposedly it worked. And another thing that they did, which was very effective, which a lot of cybercrime groups are using, is called SIM swapping.
And how does SIM swapping work?
So it's a form of social engineering where basically you collect a bunch of information about someone. Let's say, I know your mother's maiden name, I know what your first school was, whatever, a bunch of personal details, and I know your credit card number. So I call your mobile provider and I say, hello, I'm Eden. I've lost my phone. Oh no, my phone is my life.
Unfortunately.
Please help me. And then the phone company will say, oh, okay, let's prove that you're really Eden. And then I'll give them my credit card number, your credit card number.
It's hard to be Eden.
Yeah, it's really hard, but somehow I'll make it work. And then bottom line, they reactivate my phone with your phone number. And at no point did they contact you. At no point did they contact your employer. And that's it. Someone's stolen your identity. And now if you are getting 2-factor authentication codes to your phone, then
it's not going to you.
Exactly. And often that's like the only boundary. Like a lot of companies, multi-factor authentication is like the only thing preventing you from getting in, as long as you have someone's password.
So what you should do is get a YubiKey.
Yes. The most effective thing you can do against SIM swapping is to avoid using anything involving a mobile provider, like don't use SMS-based, don't use call-based. I will say that it is far better than nothing. Like if you don't have any form of two-factor authentication, then...
But it's really easy to log in.
Yes. Like it's all you need is a weak password or something that's vulnerable to brute forcing, and that's it. But I think what the review board sort of pointed out was that yes, it's better than nothing, but you still aren't really in a good position against LAPSUS-like groups, which means that you're probably in a far worse position against, again, Chinese and Russian threat actors. So yes, using an authentication app or using a security key like YubiKey, which we all know and love.
I have a YubiKey.
As you should. That's a very effective means of protecting against SIM swapping.
Cool. But another interesting angle is another threat that's kind of on the rise or potentially up and coming, which is data poisoning during AI model training.
Yes.
This came to light during a talk that was given at Black Hat about hackers might poison the data that's being used to train generative AI models. An example of this would be that you have like an AI security monitor that is able to understand if something is potentially good or bad. And then all of a sudden it starts missing a bunch of bad stuff because someone poisoned it, and then you can use your imagination to think of what they would do next.
Exactly. And like it's not even in just security, like that could be the same for like a medical device that differentiates between like a good X-ray and a bad X-ray, right?
You're good to go. And you're like
Cancer-free.
deathly ill.
Yeah.
Okay, so how would this work? How would you poison this data?
So data poisoning is the term for when an attacker gains access to the data that you are using to train your model, which is usually a very large corpus of like images or text or stuff like that. And once they can control that content, then they can indirectly control the way your model behaves, because the model is always a function of the data that it's based on. And with the very large models, a lot of these data sets are what's known as uncurated, meaning that it's not like you personally reviewed every single image and said, yes, this is what I mean, this is what I need. You source it from the internet, you source it from possibly your own data. If you're like a company, you have a bunch of proprietary data about your users, you might source it from there, but it's not like manually reviewed. And if an attacker has access to it, then you might not even know that they changed anything. And this is what this research was about. It was basically saying, if you are sourcing your data from like Wikipedia, and an attacker can edit Wikipedia,
I can edit Wikipedia.
You can edit, yeah, exactly.
Anyone
Anybody
can. Like the ease of it is quite accessible.
Exactly. But like a content moderator will come along, probably even within a few minutes or a few hours, and revert the edit that you made.
But if they know exactly when you're going to make the pull, then they can...
Exactly. So if an attacker can figure out when you're ingesting data from Wikipedia, let's say every day at 3 o'clock, you copy the entirety of Wikipedia to retrain your model. So if an attacker can figure out what time you're doing that, they can quickly make an edit. You copy, a content moderator will come along, revert the edit, but
You'll
you
never
wouldn't
even know.
Exactly.
So one mitigation against this is making sure you kind of randomize your ingestion schedule so you're not predictably attackable.
Right. That is the antidote.
That is the antidote. Okay, what else can you do? And what else can they do?
So another thing that was really interesting was if a lot of times like you're not actually storing all the data in one place, basically your training system is calling out to a bunch of different servers all over the world on which it knows that images or texts are stored, such as Wikipedia, for example. So Wikipedia isn't much of a problem because it's a very well-known thing, it's well-maintained. Wikipedia is still around. If you go to wikipedia.com, you're going to find, or wikipedia.org or whatever, you're going to find Wikipedia. But let's say that your model is expected to be trained on like just some random image stored somewhere on some website. And let's say that that website existed at the moment that you decided to train your model on it. But let's say that the company went bankrupt and then the domain expired. But that URL is still in your list of data to train on. So what if someone comes along,
steals the domain,
exactly,
and does
whatever they want, right? They put like the wrong image there, or they put text that contains a mistake. And if they can do this for a significant enough amount of domains, they might be able to even gain a significant percentage of your model and actually poison it.
Quite scary.
Yes.
So you should monitor the domains that you're...
Yeah, like there's a few things you can do here. One is you can avoid ingesting data from domains that have expired. You can run your own monitor on making sure that domains haven't exchanged hands, although that's a bit difficult because domains might be transferred all the time. You know, maybe the company just switched their IP address, whatever. If it's data that you control, then you're in a far better position to do this. You can actually have, you know, a scan on a regular basis that can determine if you have any domains that have been forgotten.
Yeah.
But the best thing you can do, and this is what they suggested in their research paper, is just hash the content that you expect the model to be trained on and then verify its integrity when you're downloading it. And then you can just make a comparison, and if the data has changed,
you know.
Yeah, that might be an indicator that someone has tried to poison you.
Fascinating. Okay, so to wrap up this story, what are the takeaways for our listeners regarding the data poisoning?
So I think one is that data poisoning does seem like a genuine risk. I will say that there aren't...
Be scared.
No, so you know, be reasonably scared.
Be vigilant.
Be on the lookout. I will say that they also mentioned this in their report, and I tend to agree. I don't think there have been any cases, or at least well-known cases, where this has actually happened because attackers took advantage of this weakness. Like, I don't remember there being any recent cases where someone actually poisoned the model and it had like a real-life impact on someone. Like, it didn't, you know, cause someone to die or whatever. Like, mostly it's just
not dramatic at all.
Yeah, like mostly it's still in the realm of academia. But I think it's probably a matter of time before, you know, something like this happens, unless we all remain vigilant, unless, you know, we all make sure that our models are well secured. And other than that, just do what they suggested, which is make sure that you
use a hash, randomize your ingestion schedule, and monitor for domains that
have expired. Exactly.
Cool. For our third story, we have the WinRAR 0 day that was exploited against crypto traders.
As usual.
So WinRAR is a tool because Windows didn't allow you to create or open zip files.
You know, you have like iPhone versus Android.
Yeah.
So it used to be that you had like RAR versus zip.
Oh, okay. I didn't know RAR.
Yeah. So that was like the format wars, right?
Cool.
So nowadays...
But now it lets you zip and not RAR.
So Windows now has native support for zip.
But not RAR still.
As far as I know, yes.
Okay, good to know. So WinRAR is a tool that allows you to create or open zip or RAR files.
Yes.
Because at some point in time, you couldn't do either on Windows, and now you can't do RAR.
And it used to be that bandwidth was like a thing. You had to worry as a person who was using like a 56K modem.
I think you're aging yourself.
I am definitely aging myself. You know, you didn't, instead of sending a 100 megabyte file, which used to be a lot, you could send like an 80 megabyte file, which saved you time and money, right?
Wow.
Using WinRAR.
Nifty. Okay, so how does the CVE against WinRAR work?
So the story here is that crypto traders were being hacked. Nobody really understood why. It was all happening on this forum where people were like sharing files with each other. So like you're on the forum, someone says, "Oh, I found a cool thing you can do with Bitcoin." And then you open the file and then you run like a document and you're like, okay, it's a document. What could possibly happen if I open a document?
A lot could possibly happen if you open a document.
And then suddenly you have malware. So then researchers came along and started looking into this, and they realized that something really weird was going on here, and they actually discovered that it was a zero-day vulnerability that an attacker was using. And the zero-day vulnerability was basically that if you had a document or an image with a certain name, you could specially craft the WinRAR file to run a script that was also contained within the archive, and it would be run instead of the image, which is not what you expect to happen. Like, you expect that if you open a RAR file, you open a document, then you'll expect the document to run and that's it. But in this case, other stuff was going on, which is bad and can be taken advantage of, which they did.
Which is what quite specifically happened. WinRAR is probably more common in on-prem environments than the cloud.
So I'm guessing it is. I didn't check this, but I'm assuming that it also exists in the cloud, possibly like pre-installed on a bunch of container images or stuff like that. I'm assuming it also does exist in the cloud. The question is more where it is actually being run. So if you have a personal computer, then you might be using WinRAR. But if you run a server, then you're probably not using WinRAR on a regular basis. And if you are using it, you're probably not using it to run stuff that you don't know where it came from. It might be like part of your production infrastructure where like you're transferring files from place to place and you compress them using RAR, fine. But you're probably not doing it with just like any file you find on the internet, which matters because that basically means that if you have only trusted RAR files, this vulnerability is less likely to affect you. The only case I could think of where it might be likely in a cloud environment to be relevant is if you have a file scanner. For example, if you have like ClamAV, which is an antivirus that often protects mail servers, and we spoke about in a previous episode, as you
Yes,
probably
we did.
remember. So if you have ClamAV, someone sends someone in your organization an email with an attachment that's a WinRAR file that happens to be exploiting this vulnerability, then ClamAV will open the RAR, try to execute stuff. It'll get infected, but it's built for that because like it's sandboxed and it's running under the assumption that people are going to try to hack it and going to try to execute stuff that they're not supposed to. So in that case, you're fine because you probably have a bunch of security boundaries. You probably have a sandbox. But other than that, servers tend just not to click on stuff randomly. So I would say that bottom line, this is of pretty low concern for cloud environments, unless you have virtual desktops.
In which case, patch.
Yes.
Cool. We are introducing a new thing. It's the vulnerability speed round.
New age.
It's for vulnerabilities that you should know about, but aren't hip enough for us to.
They didn't pass.
They didn't make the cut.
Yeah, they didn't pass the line on our hip meter.
Cool. For the first one, we have attackers exploiting a critical vulnerability in an Apache Rocket MQ to install the Dreambus bot.
Yes, they are. So Dreambus is an interesting botnet in the sense that they attack cloud environments as well. And they have a wide array of techniques at their disposal. They use a bunch of different vulnerabilities in common software, and they also exploit misconfigurations in applications, like applications that don't have authentication set up, stuff like that. One interesting thing was that I think the report mentioned that Dreambus hasn't been observed in the wild, at least publicly, since 2021. We've actually seen them since then a few times, trying to target our customer environments. So they're definitely something to watch out for. This is like the latest thing they've added to their arsenal, and it's probably going to keep going.
The second vulnerability is attackers exploiting a GitLab vulnerability and abusing vulnerable resources for both cryptojacking and proxy jacking.
Yeah, I think we spoke about proxy jacking on a previous episode. It's basically when instead of taking advantage of compute, in the case of cryptojacking, proxy jacking, you're basically taking advantage of networking capacity. So you're taking up bandwidth and having the victim pay too much for what you're doing with their resources. Like you could use that for transferring data from place to place, funneling stuff from one part of your botnet to another part of your botnet, stuff like that. Or even like offering the targeted server as a proxy, as a service for money to one of your shady customers, for example.
And for the third one, we have 3 high severity privilege escalation vulnerabilities in Kubernetes that were recently published. And the Kubernetes clusters that are affected are only if they include Windows nodes.
Exactly. Also pretty rare, like Kubernetes doesn't have a whole lot of higher critical vulnerabilities. When they do, then you should pay attention because they affect basically everything. Specifically, I know that in AWS, customers of EKS had to patch this manually, like they had to take action in order to make sure that they were well protected. I'm not sure how popular Windows nodes are in Kubernetes, like across the board. I'm assuming they're rarer than Linux. But if you are using Windows Node in your Kubernetes clusters, then you should definitely pay attention to this because patching this is an easy way to reduce attack surface.
Cool. That's it. That's it for our stories for today. What are our podaways?
Our take-a-pods.
Yeah, our takeaways. For the first story, there was the LAPSUS hackers that were revealed.
So make sure your organization is well protected against SIM swapping. Don't use SMS or call-based authentication methods. It's best to use MFA with an authentication app or with a YubiKey, for example.
Fab. For the second one of data poisoning during AI model training.
So there is an antidote. If you are sourcing external info for your AI model training, you should randomize when you ingest that data, and you should hash it in order to verify its integrity.
Noted. And for our third story, the crypto traders that were targeted by the WinRAR 0 day.
For cloud customers, this is only really of concern if they're using virtual desktops, so they should patch those. Otherwise, this is probably low concern, and you can move on with your day to other more important vulnerabilities.
We're having a good meal.
Go outside.
Yeah, take a run. That is all for this episode of Crying Out Cloud, presented by the cloud security company Wiz. If you enjoyed the show, be sure to subscribe, give us a rating, and remember that unlike your IAM policies, more stars is better. And as always, if your cloud security strategy is making you cry, don't worry, just cry out cloud.